We have already started with chapter number 2, and in that we have finished with an assembly language scheme. Now in this lecture we will see the point pass structure of assemblers. I, Professor Devi Kosti, welcome you for this lecture. So let us see what is meant by pass. So pass is the complete scan of a source program. That means when a complete source program is read once, that is called as pass. Now, pass structure of assembler includes two different schemes, that is, two pass assembly scheme and single pass assembly scheme. This is pass. This is pass, okay? Single pass scheme. So, two pass assembly scheme and single pass assembly scheme. Let us start with two pass translation first. So as we have seen many times that there is something phase 1 and phase 2, there is something pass 1 and pass 2 that comes under two pass translation. So it can handle forward references easily as first pass will do LC processing and creates IR. Now you know what is meant by IR. IR is nothing but intermediate representation which consists of symbol tables, different tables we can say, and along with that intermediate code. So this is the task of first pass in two pass translation. Simply we can say that first pass will perform analysis phase. Now in this second pass uses IR, that is nothing but symbol table, literal table, constant table and IC, and gives target program. Now whatever is done, that is pass 1 for generation of IR and pass 2 for generation of target program, is called as two pass translation. Simply we can say that synthesis is performed by the second pass. Now let us see the diagram for two pass translation. So this is what the diagram for two pass translation. You can see here source program is given input to the pass 1. This pass 1 generates different data structures. Mnemonic table is already present. Symbol table is generated. IC is generated. So in combination of all is nothing but IR. Now the pass 2 takes IR, uses mnemonic table and different tables present over here from the data structures and generates target program. So whatever is this dot arrow is there, this is called as control transfer. That means when two pass translation starts working, first of all pass 1 will come into picture. The control is with pass 1. Pass 1 takes source program as input. It generates IR, uses different data structures, fills symbol table, constant table, literal table, and after that, once the complete scan is performed by pass 1, then the control is transferred to pass 2. Now pass 2 will start working. Pass 2 uses data structures along with IR and generates the target program. So this dotted arrow is called as control transfer. I hope you understood two pass translation. So already we have seen such a diagram with heading analysis phase and synthesis phase. So analysis phase, that is done by the pass 1 and synthesis is done by the pass 2. Okay. Now let us switch to the second type of translation, that is single pass translation. So here a little bit theoretical part, but you will come to know that that when we will see the comparison between two pass translation and single pass translation, you will easily understand this. In two pass translation, as the name indicates, two pass translation, two passes are included there. That means two times scanning is done. Here, in single pass translation, a program is scanned only once. So there is nothing like pass 1 and pass 2. Clear? In two pass translation, there are two different steps, pass 1 and pass 2. In single pass translation, there is nothing like that. It is clear single pass translation. Now, here LC processing is done, and at the same time symbol table is also constructed. But there is a problem of forward reference. Now, such a forward reference problem is tackled using a process called as backpatching. Now, we must know what is meant by backpatching. Backpatching is the process of getting the information of a particular symbol which is present later on in the program and taking that information and put back to the symbol table. Such a process is called as backpatching. I will explain it diagrammatically. Suppose here is a particular symbol T. Now we don't know the address, we don't know the value of T, we don't know address of T, but this program will search for T. Somewhere we will find the symbol T like this. Declare constant T as a 10. Suppose T's value is 10, which is encountered later on in the program. Now what single pass translation will do, once it finds T, it will enter this T into the table of incomplete instruction. It will search for T. Once it gets the information of T, it will backpatch the information into the symbol table. So this process is called as backpatching. Operand field of instruction containing forward reference is left blank. That's what I told right now. And once it is encountered, it is put at a blank space. The need of inserting the second operand's address at later stage can be indicated by adding an entry to the table of incomplete instruction. So table of incomplete instruction, that is TII, will hold the information of such symbols which are having incomplete instruction. Once that information is found, it is placed at the respective position using a technique named as backpatching. By the time end statement is processed, symbol table obviously would contain all the addresses, and table of incomplete instruction would contain information of all forward references. Now, assembler can now process each entry in the table of incomplete instruction to complete concerned instruction. So I hope you understood that table of incomplete instruction is finally completed, because before we visit the end statement, we got all the information of all the symbols which are forward referenced. This is called as single pass translation. So single pass translation is generally time consuming because many times backpatching is to be done. Many times a lot of things are to be modified. Whereas in two pass translation, in a single scan, every information is collected and stored. And in the second pass, each and every information, whatever is gathered in the pass one, is used to perform the translation. So this is what we have learned. We have seen the pass structure of assembler, in which we have two pass translation and single pass translation. I hope you understood this. Thank you and happy learning.